All right, in this session, I have pulled up SPSS, and I want us to just do a little bit of practice looking at skewness and kurtosis just for some very small sets of data. So I have here the SPSS data editor, and you see it looks a lot like Excel, right? So what I want to do is just go into the variable view and just give these variables a couple of names. So we can even call it practice 1. And if you've noticed, SPSS does not like spaces in the variable names. And we'll call this practice 2. Oh, did it change? Did I not click down? Okay, let me do it again. Practice 1. There we go. And then practice, oops, didn't like spaces. I'm going to kick that back over there. Practice 2. And then practice 3. Okay. All right, so I'm going to think back to that last PowerPoint where it had a few just very tiny sets of scores, and it asked us to give an idea of whether or not that kurtosis would be positive or negative. So I'm going to pop those numbers in. The first one, they gave us the value of 1, 2, 3, 4, remember that? Oh, and 5. And then in the second one, it was slightly different. So it was 1, 2, 2, 2, 3. And then in the third one, remember, it was all 3s. Okay. And just to refresh your memory, we said for practice 1, we said that kurtosis was going to be negative, because when we drew it very roughly, it looked like that kind of that curve that we drew over our scores was going to be kind of flat, pretty flat, so platykurtic. In practice 2, we said that was probably going to be positive because it appeared when we drew it roughly that it would be tall and thin. And then in practice 3, we said, it cannot be determined because we do not have a standard deviation. All right, so what I want to do is go ahead and run those. So let's do analyze and descriptives. So you've probably found by now that you can get skewness and kurtosis either under frequencies or descriptives, and it really doesn't matter which way you go. Here, if you go through frequencies, just turn off display frequency tables, because we don't want to know how many 1s and 2s and 3s we have. We kind of already know that. But under statistics, I want to click on skewness and kurtosis. I'm also going to ask it for mean and standard deviation, just because that's what we were talking about earlier in our beginning discussion of skewness and kurtosis, how we needed a little more than mean and standard deviation. So the variables I want that information for, I'm going to click over here. And I actually want that information for all 3 of my variables. And I want to click under charts and see. I actually want a histogram for each of these because I'm kind of a visual person and I want to see that histogram and what those scores look like. And hopefully it'll be a better picture than my little scratches on the PowerPoint. So, all right. So I went to analyze, descriptives, and then frequencies. I clicked over the variables I care about, which are all 3 in this case. I went to statistics, told it what I wanted, mean, standard deviation, skewness, kurtosis, and then I asked it for histograms. And I want to show that curve on the histogram. All right, so let's see what we have here. Okay, so let's look here. This tells us that we have 5 valid scores for each variable. The mean for practice 1 was 3, the mean for practice 2 is 0, and the mean for practice 3 was 3. All right, then it gives us the standard deviation for each of them. Okay, skewness value is 0 and 0. Kurtosis, though, let's see if we were right. On that first 1, 2, 3, 4, 5, we said it would be negative, and indeed it is negative. And then the next one, we said it would be positive, and it is. Now, the standard error of skewness and the standard error of kurtosis, we're not going to use those right now, but when we get into next semester and we're checking for normality and doing some other things, we are going to bring in that standard error of kurtosis and skewness. So for now, just kind of mentally block that out, and let's just focus on the skewness value and just the kurtosis value. All right, so let's look at our histograms. Okay, now this is for practice 1 where we had that data that was just 1, 2, 3, 4, 5. What you need to notice here is your scale on the side. All right, so the x-axis counts by 1, 2, 3, 4, 5, right? And we had one of each. Over on the y-axis, though, they are counting by 0.25, right? So we could go in and change the scaling so that maybe our 1.0 was right here instead of way up here. Because this is giving us kind of I think, a distorted look at our data. I don't know, it's a little bit strange. But we could go in and rescale it so that it would look a little more like what we drew, but it's essentially what we drew. So what they do here is, this is the normal curve. See what I mean? And so they don't alter their line like we did with our little sketch. And so that's why it looks a little bit strange. But if they had altered their line, it would have gone right over the top like ours did. But like we said, we do know that kurtosis was indeed negative, right? Skewness, on the other hand, is 0, because we could take that distribution and fold it right on the mean, right in half. Remember, it said our mean is 3. We could fold it right in half on 3 and have the two sides match. So the fact that skewness is 0 makes perfect sense, because it is symmetrical, but it's really a short and flat distribution. So we have a negative kurtosis. All right, let's look at the next one. Here we go. So this was our next one. We have practice 2. We had 1, 1, and 1, 3, and then mostly 2s. And see, to me, this is very weird. I wish it would just be numbered by 1, because I think the 1.5 and the 2.5 and the 3.5, it's just strange to me. But you know, our values that we had were 1, several 2s, and then a 3. And you can see that here we had 1, 1, 1, and 1, 3, and then we had 3 2s. All right, so definitely a taller and thinner distribution. So it was positive. It is symmetrical, because look, if the mean is 2, if we folded it right on that mean, we would have symmetry. But because we don't have that nice, pretty height to width ratio, then it is going to be a positive kurtosis. Not crazy positive, but definitely some positive. And then 3, there's 3. Everything's the same. No standard deviation. All right, so let's look up here at the third one. Okay, so notice how these are blank. It's not able to be determined, is it? Right, and I'd have to look into it to see why is it giving us a standard error of skewness and kurtosis. That seems weird. So I'll check into that, but what I wanted you to see primarily is this missing value in the kurtosis area, which lines up with what we talked about. If there's no standard deviation, if it's 0, then we cannot calculate kurtosis. All right? So let me see if we can do something here. One last thing on SPSS. Let's create a practice 4 variable. And this is something that the students and I do together. It's kind of fun. The first task I give them is, if we're dealing with 10 numbers, let's pick 10 numbers, a set of 10 numbers, a distribution of 10 numbers that we could kind of manipulate to make it have 0 skewness and 0 kurtosis. So it's going to be that nice, beautiful distribution. All right, so if I'm just thinking simple numbers, all right, I'm imagining in my head what that would look like. If I was just going 1 through 10, let's say, I might have 1, 1, and then maybe a couple 2s, and then maybe 3 3s. Let's just go 1 to 5. How about that? I think that'll be easier to kind of maneuver and make it be perfectly symmetrical and height to width ratio. All right, so envision in your mind, what is this going to look like? I see 1 and then 2 2s, 3 3s, so I'm kind of getting taller there, and I have, what do I have left? I have 1, 2, 3, 4 spots left. Well, I know this one needs to be a 5, right? And I need a couple 4s, so I'm going to make that a 3. Okay, so I think this is going to be perfectly distributed. I think it's going to be, it's symmetrical. It's definitely symmetrical. I can see that. And I think it's going to have that nice height to width ratio, which would mean kurtosis would also be 0. So let's check that and see. So I'm going to go back to analyze descriptives, frequencies. I'm going to take these out because I don't need them anymore. I just want to look at number 4, and everything else should be still clicked on that we clicked on before. It doesn't go away until you shut down SPSS, so everything should be still kind of turned on, I guess you could say. All right, I'm going to say okay. Now here I want to point out that if you haven't noticed yet, when you're running SPSS, whatever you do, it just attaches it to your next thing or to your previous thing. So the analyses that we did earlier a couple minutes ago, they're here, and if I scroll up, it's here, because this, as I'm sure you figured out, is your output file. So you have the data file, which is .sav, and then you have an output file, which is here. So if I did save as, this is going to be an SPV file. So this is your output, which is different from, of course, your data file. Your data file is the .sav. Okay, so this is your output. Everything you do until you save this output file and close it, if you want to save it, but until you close it, it's just going to keep like a running record of everything you've done. Kind of like those old-fashioned adding machines with the tape that comes out. It's just a running record of everything you've done. So there's what we did first. And then it kind of gives you, so this is the syntax. These are the commands. So before, and still in other data processing software, you have to type the syntax. Like there's R, which is a free data analysis software, but the learning curve is pretty steep because you do have to learn the coding to get it to happen. SPSS is point and click, which is for the applied user is much easier. Now if you're going to go into research of some type, then you would definitely want to learn the code commands, and they're constantly evolving, right, as the versions, as they come out with new versions, and then as new analyses are developed, then the coding changes a little bit, but you just figure it out as you go. Another big analysis software called SAS, it's also more code driven, not as much as R, but it definitely more than SPSS. So anyway, sorry to get off on that tangent, but you can kind of tell when you're about to shift to your next thing because of this log right here. So here's the log, and that's what it is. It's just basically saying, okay, this is what you told me to do, and these are the commands I ran. And then it gives us really nice, kind of user-friendly bit of information here. So if we look, our goal was to have 0 skewness, which we did, but look, our kurtosis is off a little bit. So that height to width ratio is off a little bit. All right, so let me look at my histogram. Sometimes that helps. Okay. All right, see there? We have 2 of those and 4 3s. Yeah, you see how we're just a smidgen tall and thin. So let me go back. Let me see what I can do to the 4s and the 2s to get them a little more right, because we want that nice, beautiful height to width ratio, that nice kind of bell curve. And again, we're good on symmetry, so we don't want to mess with our symmetry. So let me click back over to my data. All right, so what it was showing me was that there's too much of a jump between my 2 to 3 and also my 4 to 3. So I'm wondering, what if I changed this to like a 3.5? And then I create a little transition here. No, wait, is that right? Yeah, 3.5. Let me create a transition here and do 2.5. See if we can get a little bit better. And again, in class, the students are doing this. They're telling me what to do, what to change. And it's a good discussion because inevitably there are people who sit there and think, what in the world is she talking about? And what I like about it is the other students who are saying things like, oh, change it to 2.5 or 3.5. That allows their classmates or their colleagues to really explain to the student who's not really understanding what we're doing, why we're doing that. And so the explainer and the explainee can both grow and learn from the exchange. So I made my little changes. I'm going to go in and try it again. Remember, I'm trying to get our kurtosis to be 0. Let's see. And I can, everything's the same. I don't have to go back and re-click anything because I haven't shut down SPSS. I'm going to say okay. Oh, dang it, look at that. Now I've gone to kurtosis is negative. So I've gotten too flat, right? I changed it too much. Let's look at the picture and see what I messed up. Ah, that looks terrible. What did I do wrong? Okay. Let's see. I have 2 2s, 2 3s, and 2 4s, and just a couple of those. So what do I need to do? What would be good to do? I need to bring down a couple of those, don't I? All right, let me go back to my data set and take a look. It's too flat, all right? Too flat, let's see. I wonder if I can let's try to insert case. There we go. I'm gonna insert another 3. Oh, you know what? Should that be? Yeah, 3.5. All right, let me just try it with another 3 there to try to get that middle back up. Same thing. Oh man, we're getting closer. Closer. All right, let's see what our picture looks like. We have one of those. Okay, so what do you think about adding, if I'm looking here, looks like I need to add two, what do you think? Another 2.5 and another 3.5. You want to try that? We'll do this one last thing and see if we can get it. If we can't, we'll just continue. All right, so I'm going to add one of these, 3.5, and then I'm going to come up here. I don't think I need to even add them in order. I don't even know why I'm worrying about it, because I can just put it down here. 2.5. It doesn't matter where it is. I think it was just visually easier to see. All right, so that's a good time to bring this up. If you click on it and then right click, you can sort ascending or sort descending, and it will pop it back in order for you. And you can see that it shifts all the variables, so it's not like if you're considering this like participant 1 and participant 1 scores on each of the practices, it's not going to mess up the organization of your data. It shifts all of the variables. So, but now it helps me in this little task kind of visually see what's going on here. So actually, I think I'm going to add another 3.0 just to make sure it's a little bit taller than those others. All right, so let me look at it now. Fingers crossed. Oh, dang it. Okay, now it's too positive again. So we're getting back to our leptokurtosis. But doesn't look too bad, does it? Let me go take out that 3 and see if that will help. I have one too many 3s. Okay, now let me try. Okay, now really this is the last time. But now it's like a challenge, right? Now I have to get it correct. Oh, dang it, still too big. Okay. All right, but you get the idea. We could sit around and play with this all day until we get it to be 0. Kurtosis, skewness, we're good. All right, so here's a good time to bring this up, because the question becomes, and it's a great question, if we're looking for not skewed and just normal kurtosis, what is considered normal? Kind of what are the possible ranges of these values? And so what I can tell you is in the next course, when we start looking at issues of normality, so how normally distributed is our data, because a lot of the analyses that we're going to go on to learn, ANOVA, the different types of ANOVA, there's factorial ANOVA and ANCOVA, MANOVA, multiple regression, all these different analyses within what we call the general linear model, they all depend, or they all operate under the assumption that we're dealing with normally distributed data. And so we really want our skewness and kurtosis values to be acceptable, because we want to know, hey, is that data normally distributed? And if the answer is yes, then we can just proceed with whatever we're doing. We're in good shape. So the great question becomes, well, what is considered normal? And this is just kind of free information. So if I'm looking back at my skewness and kurtosis information PowerPoint, what I want to just kind of bring you in on is a little bit of a benchmark that we use, and it was developed by, trying to get my pen to work again, there it goes. It was developed based on some work by a guy named Schuler Huck, and so he a while back, almost 15 years ago, he went in and did some what we call simulation studies to really look at the behavior of these statistics under different values of skewness and kurtosis. And so through his work, what we found was that skewness that was between -3 and +3, and the same thing for kurtosis values that fell between -3 and +3, as long as those values fell within these ranges, we could be relatively comfortable declaring that a distribution is normally distributed. And so this guy, his last name is Huck, and he actually has, and he has an updated edition, but the one that I have in hand is from 2004. And if we're writing about this, and we want to kind of say, oh, our data is normally distributed, we refer to skewness and kurtosis values, And if they're in between these values, then we cite Schuler-Huckus to say, it's not just me saying it. This guy, based on his research, he's the one who kind of indicates this is what we'll find. So if I'm thinking about this data, even though this is not 0, I can still be relatively certain, looking at skewness and looking at kurtosis, that my data is pretty normally distributed, even though I haven't hit right on 0. And in fact, I did worse than when we started, because if I go back up here to the very first one, I think it was the lowest of all, wasn't it? Well, there's 0.072. Is that the first one? Yeah, so I guess the third one was a smidgen better than our first one. But either way, we can be assured that these are relatively normally distributed, because although not completely 0, very, very close to 0, and certainly within our kind of benchmarks that have been developed through the research. Okay, so that concludes our talk of skewness and kurtosis using SPSS practice. And I'm going to stop for now.